in this area. Though I have not met him, personally, I've been to this center about a few years back. But today, a student of this, I would like to listen to more. So formally, I welcome on the entire university. I also wish this opportunity to on behalf of Agriculture University on behalf of our participants, who is the Department of Nanotechnology in US Raichur. Kerala University has been a bit late in taking up this science of nanotechnology. I'm announced to this audience that you have been in certain cities. We are also a number of things here, and also our students have been working on particles, especially nanoparticles, and also in using nanoparticles to for delivery of genes into plant systems. So slowly we are awakening to the possibilities. So ever since the nanotechnology emerged in the 1970s and early 80s, I think we have had a consensus of the science. For example, UN itself has been commented nanotechnology can deliver the millennium goals. Actually, in terms of agriculture, energy.
I think the audio is not clear, Madhu sir. I think you may switch off the video, then I think the audio may be clear. Because of the poor signal, we are not able to hear you.
Yes. Better now?
Dr. Suma, I think you may proceed because...
Yes, sir.
Yes.
Director of Research, audio is not clear. Madhu sir, your audio is not clear.
Okay, can we proceed the session? Because
yes, we will proceed, sir. Okay, thank you.
Hello.
Thank you, sir. Thank you for the introductory remarks.
Yes.
Because it's not clear. It is not clear. Yeah.
Yes, I understand. I was anticipating something like this because activity is very poor here.
Okay, Dr. Suma, please proceed. Yeah.
Hello.
Thank you, Madhu sir. I would just like to speak a few words about our eminent speakers today, though this would not do justice to their profile. Dr. K. Subramanian sir is the Director of Research and NABARD Chair at Tamil Nadu Agriculture University. Sir has over 30 years of teaching and research experience, and he is an eminent scientist in the area of nano agriculture and soil biology. He is the founder head of the Department of Nanoscience and Technology at TNAU and has been instrumental in developing a research framework of nanotechnology platforms in agriculture. He is a high-profile researcher with more than hundreds of papers to his credit, and he has also brought in more than 5 crores of research funding. Sir has been a guide to many students, and he's also an advisor on national and international platforms regarding nanotechnology in agriculture. We're very fortunate to have you, sir, on the platform today as our eminent speaker today. Dr. Sharangouda Hiregudar is the head of Center for Nanotechnology at UAS Raichur, an alumnus of College of Agriculture Engineering Raichur, GKBK Bangalore, and a PDF from Canada. He is currently heading research in this very emergent area of nanotechnology in agriculture. He, among many of his accolades, he is also a fast-track young scientist of the DST and has over 100 research publications and is involved in students' guidance. He's also a fellow of the FISCA. And again, we are very fortunate to have him also as a speaker with us today. I would like to request Professor Sudheer KP to kindly take over the session. Professor Sudheer is the moderator for this webinar today, and he, being the head of the Agri-Business Incubator at KAU, is the right person to conduct the proceedings of the session today. May I request Professor Sudheer KP to kindly take over the webinar.
Thank you, Dr. Suma. And thank you, Dr. Madhu Subramanian, Director of Research, Kerala Agriculture University, for making the introductory remarks. Though we missed the introductory remarks speech because of the poor signal problem at I think our director of research from TNAU will compensate that. Okay. I'm sure that as the welcome speaker, Dr. Suma mentioned about he is one of the doyen in the area of nanotechnology, and we all know that nanotechnology is there in every spheres of agriculture, starting from the production to the consumer till it reaches into production, then soil modification, then plant protection, then processing, packaging, transportation, everywhere. So I think the best speaker we can think about in nanotechnology. When I thought about a webinar, then the name come to my mind is our Dr. Subramanian Sir, KS of founder member of our nanotechnology center of TNAU. And I am also an alumni of TNAU, sir. And now it is my pleasure to introduce you as well as to welcome you to the webinar. And now the floor is open to you, sir. Please you can start your presentation.
Yes. I can share my PPT. Yeah?
Yes, yes.
Good afternoon, and respected Vice Chancellor, Director of Research, Professor Sudheer, and other organizers. And it's an exciting moment for me to speak because a few hours ago I was speaking nanotechnology, how we take nanotechnology in the country in one of the important meetings that Sudheer may be aware of. It's called Prime Minister Babu program. In which we connect nanotechnology of India with the foreign countries. There were about 7 countries participated in the discussion. And I could see, though we are early birds in nanotechnology in the country, and we are way ahead in terms of accomplishments. So there comes TNAU is very important in nanotechnology research in the country. And I'm showing a couple of pictures I show how exactly we entered into nano. I come from soil science, basically soil science, and turned to be a soil biologist when I did PhD at the University of Ottawa in Canada. And after my return, this is one of the niche area I started working since 2009. And the picture which I am showing indicates 1909 is the year in which TNAU started. Exactly 100 years later, the nanotechnology was built, and I was the founder head of nanotechnology. The way in which this works, 1909 till 2009, it is 100 years. In between, there was a major landmark event happened in nanotechnology. That event I always refer. He is the father of nanotechnology. We call it as Dr. Richard Feynman, who mentioned in 1959, plenty of space at the bottom. You don't look at the macro scale, you look at the micro scale and nano scale so that the process and product would be precise. So that is a turning point in 1959, December 29. Exactly 50 years later, I became head of the Department of Nanotechnology in 2009, and that's the way I started. And that's why I said it's a small guys and big business. Certainly, you will be impressed at the end of my talk. And I always explain for a common crowd that the nano is 1 billionth of a meter. And I always show India population. That's the way you can remember easily how the nano is defined. Nano, by definition, 1 by 100 crore. We have 137 crore population. If you had a chance to assemble them in what meter length, each Indian is the size of a nanoparticle. That's the way this picture indicates. So if you look at the macro material as a cube, it has 6 sides. If you divide 24 times a division, you can achieve nano-sized particle. As a cube, it has a 6 surface area, and it can spread 1 meter square at the max. And the same cube, if undergoes a division, you reach a nano-sized particle. When it becomes a nano, you can spread the entire football stadium with one small cube. That is the greatest potential of nanotechnology. That's what we try to use it in agriculture. So, by definition, atom by atom manipulation is nanotechnology. So how do we do? I think as Dr. Sudheer was telling me, there are lots of international participants as well. I just want to put it in perspective, those who listen to me, because it's a business meet, more of investment, how exactly we can progress. That's why I present this particular presentation more of business direction rather than the science part of it. And the top 10 players in nanotechnology is Japan, USA, China, Germany. The list is there. India is nowhere. Actually, we have to thank Dr. APJ Abdul Kalam for this. When he was the president of India, he was a person motivated. Think of nanotechnology. I am one of the guys who got motivated. That's the way I got the word nano. Maybe undergraduate level, I never heard of the word nano. Even 2008, first time I heard a word nano from Dr. APJ Abdul Kalam. In 2009, I became head of the department of the technology, which is least known at that time. Now, in 10 years of experience in this, fascinating field of nanotechnology, I find this area has a huge potential. The India can progress very well. The Prime Minister mentioned this particular program is very important because he mentioned in 2018 Independence Day, he said nano can go for the field. That's a big gear now. Now we all cheered up because the country is supporting, university is supporting, everybody across the board supporting nanotechnology. So this picture indicates there are top 10 players, India is nowhere. So there is a huge potential. So as a result of more investment in nanotechnology, certainly lots of research institutes have been done. And again, no Asian universities are in nowhere in nanotechnology at the global scale. So publication is very, very limited. The Chinese doing very well. Many of the US universities doing very well. So again, global publication, again, it is a distribution pattern indicates a major part of nanotechnology investment in on electronics, communication, medicine, health sciences. Very, very little amount of investment or output from agriculture. Again, there is a scope we can promote. One such remarkable invention that really changed the world is it's a mobile. 10, 20 years ago, maybe 30 years ago, when I went abroad after joining in TNAU, at that time the communication was very, very weak. Just to send a one-page fax, you have to travel 65 kilometers, stay it in Coimbatore for a day in a lodge. Then you have to send a fax, just one page. At that time it was 200 pages per. Now see the revolution, revolution. You may be aware each mobile has a small chip called the Intel chip, which has a carrying capacity of huge. It is as good as the brain. Of course, brain memory power cannot be compared. Brain power is about 1 trillion byte, and 100 or 500 computers put together makes one human brain. But it is a very powerful thing can be done with it. That is a typical example of success in nanotechnology. Global publication within agriculture, though I said very little amount of work has been done agriculture. That's why we became very popular because very limited number of scientists have chosen this kind of a challenging area in this area. So if you split the areas of interest in agriculture, of course, major part is food system. Of course, Kerala is known for spices. Kerala is known for medicinal plant. And those are the research we can do. Wonderful research can be done. Metabolites can be extracted. We can customize the product and we can derive lots of benefit out of that. And key institute in the country, mostly IITs and Indian Institute of Science, DRDO, those institutes CSIR laboratory, DAE, all involved. Again, there is no agriculture university involved. We started getting information. I think first nanotechnology training I attended in Punjab Agriculture University in 2007. 2008, I went to Cornell, USA, and there I think KV would have spoke yesterday, and I was with them for 2 months. And then I took a team of TNAU scientists. That's the way we learned. We learned a lot. We learned over the years, and we became very powerful these days. Again, agriculture is nowhere. So overall publication, again, as a result of investment is less, infrastructure for nanotechnology research is less, publication also very limited. IITs and IAC, they are the guys who worked, and the DRDO is another major organization helped in understanding nanotechnology better, because there are lots of security related products are being developed using nanotechnology. That's the way Abdul Kalam has wanted to use this nanotechnology in many ways. So output of nanotechnology, if you again the investment within the country, NASF that is for agriculture, nanotechnology is very limited. Again, there is a huge scope that nanotechnology can grow. I think I start from here now, and this is the way it worked out. The amount of investment in nanotechnology research in the country in the 11th 5-year plan is about 1,000 crore, and in 12th 5-year plan is about 2,000 crore. In both the cases, agriculture is almost like ground. So it was about 1 crore in 11th 5-year plan that came to TNAU, and in 12th 5-year plan is about 3 to 4 crore. Again, it came to TNAU. TNAU was the only institute. We worked from the beginning, and that's the way we became very powerful in this area of research. And certainly there is a lot of scope for a population of India. 800 to 900 million people still depend on agriculture. Certainly there is a loss of scope for agriculture. So why do we need to use nanotechnology in agriculture? This is a typical transformation that happened at the time of independence, or at the time of beginning of green revolution period. These are this type of people we had. We were begging for food from other country. We were using traditional agriculture. Now in 2020, we are totally transformed. We are looking at drones. We are looking at artificial intelligence. We are looking for robotics. We want to get it done everything by mobile. Typically, that is what nano agriculture. I gave the nano agriculture definition. It is given here. Infusing nanotechnology concepts and principles in agriculture sciences so that process and products would be precise to deliver input. We need to have a precise input. That is what the core idea of nanotechnology. So we have been using fertilizers, we have been using pesticide. If you look at the use efficiency, hardly exceeds 1/3 of it. 2/3 is wasted, going to the environment, spoiling soil, spoiling water, spoiling ecosystem as a whole. So there is a need for improved use efficiency, for which nanotechnology would be a solution. So what we do, I am going to, as I said, I present this particular seminar for agri business, which means what exactly business we can do out of this kind of a novel ideas or niche market. So diagnostics and monitoring system is the #1 priority for the country, and certainly the farmers are to be given correct information on the spot. That's why diagnostics is one important area. Nano agri input, I told you, improved use efficiency, nano food system, and remediation. So these are the 4 core areas in which nanotechnology is growing in different directions. Yesterday, what I find was there was a discussion on nanotechnology in agriculture. We try to look at where is the gap. If you look at the gap, almost, other than TNAU, we don't see much work has been done in within the country, or for that matter, many of the Western countries, they don't work in this area very much. So they begin to work, but far from what we have achieved so far. So certainly there is lots of scope. So diagnostics and plant health monitoring is #1 priority. So I have shown some of the lab-on-chip technologies. Some of the technologies are being developed by TNAU. Some of the technologies I took it from the other sources to show what is the development that are happening. So these are, we call it as a lab-on-chip technologies, very, very important. And the TNAU has come up with this kind of immunometry or optical sensing system where touch and deliver technology, we call it. So, which means that when you touch the plant, a small device attached to the leaf, and we will know instantly what is the moisture present or nitrogen present. And we also go to the next level of understanding is that when the sensing system attached to the app, you will get the message from in the mobile saying that plant needs water. Basically, plants send SMS to the humans how the nutrient to be done or moisture to be regulated. This way, we can regulate the irrigation scheduling, we can regulate the fertilizer application, rationalization of fertilizer is possible. Dipstick method is well known. Earlier, we call it as the ELISA method, which is time-consuming method. And the dipstick, what we developed is a very simple strip. We can measure it quickly. One of the unique advantage of nanotechnology is early detection. So many time agriculture scientists fail to address field problems because it is too late to control certain things, because farmers do not know when to sample to take them to the laboratory. Here we have a small interventions of nanomaterials that are being loaded here, and that reacts to the analyte quickly, and early detection is possible. This has been done by NRC Banana, and we can do. These are the simple examples, but we can do. It has a great potential. What is the unique advantage of what are the product which I am mentioning in comparison to what is there in the market? Is that most of the, for example, nitrogen sensing, what we do, a speedometer, it costs about 4 lakhs. But what we are aiming to get a small sensor, it is about 2,000 rupees worth. And we can instantly do that. So that is the greatest advantage. And a country like India will need that. And another unique thing India is needed, it is the on-site detection of pesticide residue. We know many places, countries producing so much of fruits and vegetables, they are not the way it is produced. And these are some of the technologies we ourselves develop in TNAU, where we can use a small cellotape loaded with a nanoparticle. When the moment the cellotape attached to the fruit, we will be able to detect what is the residue present at the nanoscale. Very trace of residues can be detected. Of course, banana disease detection is done by Colombia, and we are collaborating with them to detect a disease instantly. Again, you may be aware, TNA, Tamil Nadu state, is a forerunner in introducing Ulavan app. Ulavan is farmer app, 4.5 lakh farmers are connected. Instantly, if they take a picture and give it to, send it by WhatsApp, we know how to detect and give the solution. And e-nose is another important area of research. E-nose is an electronic nose. We can instantly know what is the quality of the seed by measuring melanoldehyde instantly. So the electronic nose is a very important device to be developed. And you may be aware, it's a COVID time. People are afraid of touching the patient, and the COVID patient, who has the power to go just like that to take swab sample, or saliva sample and so on, and very difficult time. Now people are interested dipstick type of method or e-nose. You may be aware, United States MIT is working on using sniffer dog to detect COVID patient. So that type of advancement is going on. This is an artificial intelligence product, AI product, and this is also getting popular. And at TNAU, we have got 6 projects under this particular theme area, artificial intelligence, where instantly we know what it is. It's just to take it takes lots of time to develop artificial intelligence AI product. But the moment it is developed, it is going to be a very simple app loaded into your mobile. And here, the women in Africa, they just show the mobile to the cassava plant, and we know what is the percentage of infection, and it comes with the recommendation also. And right now, TNAU is developing on whitefly infestation in cotton, where what we try to do, cotton whitefly is getting attracted with a yellow sticky trap. We take picture of yellow sticky trap continuously, and we load it to the app, and it gives instantly what is the percentage of infestation in the field. So the way in which it works, and we know how to do that. It's simply take picture. You know how to assess the infestation in the field. So that type of artificial intelligence is another important area of research. Again, it has a huge marketing potential. So I think in the diagnostics and monitoring, I have this last information about remote sensing and the geographic information system, and the satellites taking a picture on a continuous basis, on a regular basis, and you can make use of it. There is a series of success stories indicated: tsunami in 2004, flood in 2015, drought, and even Kerala flood when it happened. I took a team and we went there to Kerala with the advice of our Vice Chancellor. We made an assessment of what is the flood impact, and we gave some recommendation to the Kerala state. And one of the success story of such a image processing is a cyclone happened in the eastern part of Tamil Nadu, Tanjore, where cyclone hit the coconut plantation, and within 2 to 3 days we could make an assessment how many coconut palms have been affected. Very precisely, they come up with 38 lakh 72,000 plants. With the help of that, we recommended to the government what is the compensation to be given. So that type of instant recommendation is possible. Now, TNAU also happy to say that we have developed a smart sampling system that is recommended to the government of India, where imagery is going to be converted into insurance. Again, there is a huge potential. Claiming insurance in Indian setup is very difficult. So now the remote sensing come as a rescue to do that. And we can make use of this technology for crop assessment, soil health data, methane emission, flood impact, everything can be done. Recently, there is another important product what we developed is a soil doctor. I think Kerala Agriculture University come up with the Manu last year. That is also has a similar process, but ours is a little exhaustive than that. Soil Doctor works it's a simple app which can be loaded into your mobile. The moment you stand it in the middle of the field, and it gives a history of that particular soil. So Tamil Nadu has about 8 million soils across the state, and each and every spot we know what it is. Soil health, physical constraint, what is the likely groundwater level, soil fertility, everything can be done instantly. You don't need to do anything at all. You just click and get. So that type of device we have, and again, this is also helping. And moving further to that, I told you drone technology is coming up, and we started using drones for pesticide spray, herbicide spray, and micronutrient and health monitoring and so on. Interesting part of this drone technology is that you can use drones. You can use drones. Within 2 minutes, you could do the spray. 2 minutes only. 5 minutes per hectare, and it is efficiently done. And we have made an assessment to the impact of these drones on the impact of drone spray on pest infestation as well weed growth, and it is very efficient. Right now, 100-acre demonstration is done in 2 or 3 districts in eastern part of Tamil Nadu, where we take up drone spray against fall armyworm. I think we can do this type of work, and here there is a nano intervention, because currently whatever the pesticide, fungicide that are available in the market, that is loaded into the payload is about 15 liter, and we put it and take up a spray, which is not correct, but we need to develop a nano formulation so that the ultra low volume formulation is possible. We can do that. We also have the customized vehicle. If something to be done in the field, we take this vehicle, and these drones would be operated in a particular location and come back. So that's the way it is arranged. We have a tie-up with the MIT, Madras Institute of Technology, and Anna University, and do that. So these are the current development. Early detection of pests and diseases and monitoring is very, very important in Indian agriculture. I'm sure the industry who are listening to me will appreciate and this is the thing to grow. Another second area is nano input. The nano input also very important. And gone are those days you go with the nitrogen, phosphorus, potassium. Almost all the nutrients are required, particularly pulses. Pulses are referred as a poor man's crop, but they need a rich man diet. It requires almost all the nutrients are required by pulses. If you go with each and every nutrient, yeah, the farmers become bankrupt. So what we have done, we have taken two approaches to minimize the cost of fertilizer. So here is the Nutri capsule. The Nutri capsule is a capsule is made of nano zeolite loaded with nutrients. One capsule is enough for a plant to get nourished. So it has a complete gamut of nutrients that are loaded. It goes to the rhizosphere and fulfill it. So we have, by doing this, we can reduce the fertilizer dose by like 60% or so. And further, we want to reduce with another technology called nanofiber technology. The nanofibers are very powerful technology. This is what we had a lots of discussion on this, because there was an eminent scientist from Singapore joined yesterday. He worked on nanofiber. He published 800 paper. His name is Ziram. He has got so much of publication on this. So the nanofiber is made of polymer. The polymer solution subjected to high intensity voltage, it becomes a nanofiber. The nanofiber has a surface area of 10,000 meters square and 2,000 kilometer length. As a result, you can put anything you wanted: nutrients, bioinoculant, microbe, like inoculants, and you can put hormones. You can put insecticide, fungicide in different format, and the treated seeds looking like this. So entire agriculture go in one input called nanofiber. Nanofiber, colloquially we referred as cotton candy in Tamil we call it a panjimitai. I don't know how Kerala to pronounce it, but it is a cotton candy technology. That's we technically call nanofiber technology. And recently, TNAU also had a major, role in making the assessment of IFCO nano fertilizer. You may be aware, 2018, when Prime Minister Modi, in the Independence Day, he mentioned that nano fertilizer be recommended. So he launched this product 2018. Thereafter, ICR wanted us help to make an assessment of scientific validation of this nano fertilizer. Now it is going on. 11,000 location it is being tested. I think some of the KVKs under Kerala Agriculture University may also would have tested this. Testing is going on, and I'm the one of the guy who had to give a verdict on the safety of this particular fertilizer. So there is a huge potential for that, and we have to think about it. Other, I told you about the nanofiber technology. It can be used for pulses, oil seeds, and we have a hydrogel. Another interesting product we have is a nano silica. Silica is a very good delivery system because it's a natural mineral. We can very well use nano silica to load biomolecule and deliver to that. And the viral diseases are given lots of importance these days because after COVID-19, people are equally worried about plant viruses. The plant viruses management is very complex in Indian agriculture because the virus belongs to pathologists, vector belongs to entomologists. Always entomologists and pathologists have a quarrel between these two because which part is theirs, they don't know themselves. So now we target very specifically on how exactly virus transmission could be minimized. This is one of the beautiful example how it is done. So where we use nanosilica to load acerone or acidurectin, where it can go into the plant sap. So when the nanosilica loaded with this molecule, the transmission get affected. There is lots of work had been done. I don't want to bore you too much, but this is one of the good system. Even same system can work for COVID-19 as well. So these are some of the products that is developed at the global scale. Major part is a formulation. So the in food system, so India is known for producing so much of fruits and vegetables, and you may be aware we are second largest producer next to China. So much fruits and vegetables are produced in the country. 318 million tons are produced, more than what we eat, more than food grain we produce. but common man still struggling to get the fruits. Only problem is the post-harvest losses. The post-harvest losses is measured as 35%. Every 3 fruits produced, 1 fruit is lost. So we had one Canadian project worth 12 crore. So in that project, we have developed 6 technologies for that. We developed a formulation is made of hexanol, which is the compound naturally present in fruits, which is made as a nano emulsion. When the spray is given or a dip is given, the fruit shelf life get extended. Very interesting product. Those who are interested to test, we are giving at free of cost at this point. So we are going to commercialize very soon. Those who are listening to me from Agri business, those who wanted to take over the business, please be in touch with us. And reduce the cost of this emulsion. Right now, it costs about for mango trees about 40 rupees per tree. And we want to reduce the cost further by doing the nano sticker technology. Again, the nano fiber, we use it for loading the hexanol. A small sticker attached to the fruit box, the fruits are preserved. The cost of the sticker somewhere in 2 rupees only. So 2 rupees a sticker can help to protect a box of 3 to 4 kilos fruit, which may worth 300 to 400 rupees. So such a phenomenal, such a beautiful system we can develop with this. And we also developed a liquidator to keep the fruit fresh, the hexanol vapor. So we conducted stakeholder meeting. As I said, those who are listening from Agri business, please be in touch with us if the business to be taken by you. And another important areas of interest in nanotechnology is the encapsulation of functional foods. Very, very important in India, particularly Kerala. We have lots of medicinal plants, lots of foods are being types of being produced, and you can derive lots of nano-based foods can be developed. This is one example where after eating grapes, you split the skin, you make a nano spray dried powder. It becomes a very effective encapsulated form of food, and it can be a food color and it can be eaten as it is. We have done anthocyanin, we have done carotenoids, oleoresin, curcumin, astrogenin. I have to make a specific mentioning about astrogenin. It's a very important anti-cancerous compound, anti-cancer compound, and it is from Annona murigata. Annona murigata. Now people are worried about virus, and somebody researchers who look at it, you can examine on that. So nano packaging is another area of importance, and we have developed a film that can preserve fruits and vegetables that comes from the banana pseudo stem. After plucking the banana bunch, you get the fiber. The fiber is converted to nanocellulose. I think you have Kerala, you have a very good university, Mahatma Gandhi University. They have done lots of good work, and they also work in the similar line. And you can think of developing a film which is 100% biodegradable. Compared to normal plastic or poly film, which is degradation is in 500 years, and this film degraded within a month time, 2 weeks to 4 weeks. So I was mentioning about Annona murigata. This is the fruit, and leaf has more metabolite, acetogenin. Acetogenin is against cancer, and you can think of this. This is a very good plant, and we can do a wonderful thing on that. And nano remediation, I think this is my last part of my talk. And remediation, of course, most of the agro industries coming with the pollutants, and that has to be remediated. We have interesting nanoparticle called zero valent ion that can be used for remediating pollutants, the chromium or cadmium, heavy metals that can do the reduction. Recently, we got a project from Coconut Development Board and CDB, which is located in Cochin, and they have provided funds for a CDOT, that is carbon dot, water purification. When carbon dot, immobilized in substrate, either vermiculite, the pollution can be removed. This is a typical dyeing factory effluent that comes out from Thrissur that can be remediated very effectively. So we have done lots of good work, and if you want to take a business, one of the constraints the agri business will do is the regulation. So unless there is a regulatory framework available, you will not be able to sell the product. So what we have done, the government of India has set a team and I'm one of the core committee members in deciding look at the safety of the nano products. So this particular document came out. It's an open document. Anybody just Google for this, you will get this document. This document gives the structured way how the nano products are to be tested and how the nano products are to be validated. So I am one of the members to give the approval for those products, and you can have a look at it. And just a point I should say that when you declare that it's a nano product, you need to get the testing is done at a different trophic level, at the microbe level, predators, parasites, honeybees, earthworms, aquatic system like zebrafish, finally human cell line. So all the tests to be cleared before getting the approval for the nano products. So TNAU is one of the universities, a highly diversified university. Though we are Agri university, we have got 2 products released from TNAU for COVID-19. One such product is nano sanitizer. Though my friend developed this nano sanitizer, which is made of eugenol, and which is more powerful than what I've been working for the past 10 years, because it's a commercially viable product. It has gone out for commercial use now. And the next time you go to the market, look for nano sanitizer from TNAU. And we also put a mask. There was a call, specialized call for filtering of corona. So I am one of the guys the DST wanted me to propose. I proposed it. At least it is in the consideration. So there is lots of things have been done. As researchers, as maybe food scientists, maybe looking at the presentation, and where there is a lots of scope for community science to look at moringa. Moringa is a very good plant. I think Tamils like moringa a lot, and I think Keralites have more source of brown rice and all. They also have the equal potential, and it can be used for making drink or soup. And nanotechnology will help in terms of improving the availability. Even Prime Minister Modi is love to take roti, which is fortified with moringa. He likes moringa. He's energetic because he's eating lots of moringa. That's why people say it. Gone are those days. Bhagiraj mentioned in another direction, but our Prime Minister is taking on this. Okay, this is a beautiful view of Nanotechnology Center of TNAU. I'm happy that this was built under my supervision. So we invested 10 crore, and when I was introduced, it was 5 crore. Actually, I generated 30 crore. That is why I'm very powerful. And I am one of the guys who has the highest number of research grant in the university. The best part is that we had a good Vice Chancellor, earlier Vice Chancellor. They insisted me to go for education. That was a good advice from former Vice Chancellors. So they insisted me to go for maybe our present Vice Chancellor of KU, one of the university officer who would also recommend it, I think. PG and PhD studies were introduced, and we have got 100 theses done on nanotechnology in agriculture itself. So that is the greatest strength for us. Of course, funding from different sources is very important. And I am the guy who always look at the products. The science is relevant only when people uses the science. Science become irrelevant if people don't benefit out of science. So that was my word. This is my progress. So I started with 30 lakhs was a very little money at the time when I became head of the department. I remember when I entered as a head of the department, it was an unplastered building. I did not have the chair to sit. That was the status. Now it became a very big center. Everybody referred to it. I'm really happy about it. So we have publication till Nature, and we have got 6-7 books have been published. All of you can refer these books. I am one of the guys responsible for introducing undergraduate subject in nanotechnology. So my book is very frequently referred, this one, and it is all there in the e-book as well. So I have to thank all the funding agency who have helped me in various perspectives. Unless funds flowing, and it won't be possible. I have to thank ICR, TNAU, NABARD, Ramalinga Swami Fellowship, because I got 1.5 crore DST, DBT, CERB, and Canadian government for funding a major chunk of 12 crore. So thank you very much for the opportunity given. And folks, those who are listening to me, please remember the Indian government is going to invest at least 1,000 crore this time. That's what I heard. At least major money is going to be invested on nanotechnology. So agriculture is one of the areas of interest, and those who are interested to explore this area, you can question me, you can talk to me, you can pass on the message through Dr. Sudheer. Thank you very much for the opportunity given. Thank you.
Thank you. Thank you, Professor. And I think you have touched upon almost all spheres in agriculture segments. So your talk was insightful, and I think you are guru for almost all those who are working in the field of nanotechnology, and crores of rupees you have brought into TNAU to develop this nanotechnology. That itself it shows how far you have done in the nanotechnology aspects, and in entire spheres, I think in agriculture production segment, and even packaging and post harvest technology also. I am wondering, you have touched each and every segment in agriculture sector. So thank you for the amazing presentation. And if participants, if you have any questions, sir, please post in the Q&A section. You can see in the Q&A section. So by the time in between, you can post the questions under the Q&A section. So in between, we will go to the second speaker, sir. So will you be able to stay back, or you want to take the questions now itself? If you have any emergency, we can ask the.
So maybe a few questions, maybe 2 to 3 questions I can take, and thereafter the next
Yes.
speaker can speak, and further queries can go at the last.
The last, okay. So if you have any queries, immediately you can post in the Q&A section that sir will be taking, and otherwise, if there is no immediate question, sir, you can join after Sharangouda's presentation. Okay. So thank you, sir, once again, and definitely I don't know what to tell, because you are an encyclopedia in this area, and we are going then. We are moving to the second speaker, that is Dr. Sharangouda, my friend from Raichur campus, and he's also heading the nanotechnology division of Raichur Center. So we will see, especially the Sharangouda, what he is focusing mainly on the food aspect. Okay, the first speaker was focused on most of the agriculture production or entire supply chain, we can say, in that matter. But now we will move on to Dr. Sharangouda. He has done a lot in the food aspects, especially the food processing aspect. So let us listen to Dr. Sharangouda. So what is the application of nanotechnology in the food sector? So please, Dr. Sharangouda, it's open to you.
Thank you very much, sir. Is it audible, sir?
Audible.
Hello.
Audible.
Yes, sir. I'm just sharing the slide. Sir, is it okay?
Yes. Yes. Perfect.
Yes, sir. Thank you, sir. So, good afternoon, everybody. Respected Honorable Vice Chancellor of the KAU and respected Director of Research KAU, and just now the Encyclopedia of Nanotechnology in India, Dr. Subramanian sir has highlighted and made everyone into a nano and a clear picture what is the involvement and how the nano is going to take in the field of agriculture in the coming days. So in front of them, I may be a nano. So I'll definitely cover little areas pertaining to the what exactly and how the things is happening around the global level, and what we did in our center, and what will be the last is the toxicology and what are things. So I'm just touching certain areas, the rising era of nanotechnology in transforming food and agriculture. So thank you very much for the introduction and given the opportunity from the KU ABI department, and my special thanks to the Dr. Sudheer sir. So as sir was mentioning about the future and the growth. So there are two things in the population. So as we are aware that the day by day the increase in the populations by the just 60 years, in the less than 60 years, we are almost reaching 7 billions. But for this growth of populations, so the requirement is huge. So we have to reach a expanding production of more than 43% by 2030 to reach the current populations. So this alternative, safe way, there is none other than nano. So just for the glance of the person who have the participants may be a little aware about the nano. So I'm not going in depth about the background about and history. Just few slides. So the nano basically is 1 nanometer is almost 1 billionth of the meter. Basically it is a scale 0.1 to 100 nanometers. So if you consider an ant, almost it is a 50 lakhs in size, whereas in case of human hair it is almost 80,000. Whereas HIV virus is a 90th, and whereas atom is a 10 nanometers. So if you understand the history about the nano is not at all a new concept. Because in the olden days, the nanomaterials is traced back in a Roman period, maybe at 200 or 300 BC. So they used to put a gold chloride particles into the molten glass. They created tiny gold spheres which absorbed and reflected sunlight, and they produced the various colors. Probably they might be considered the nature. You might be aware that chameleon changes the color based upon the conditions. If the male or female comes attacks or the environmental factors, it changes colors, and based upon even the butterfly also changes its colors. So these are the basic things which is already existing in the nature. But one of the wonderful flowers is a lotus, so that's why we'll say it is a lotus effect. It is having a self-cleaning property of highly hydrophobic surfaces, and because of its nano sizes, having the 10 to 20 nanometers, wax papillae on the upper side. So even the same concept was used even in solar panels also. So solar panels is coated with this wax papillae, and they are self-cleaning processes. Even I think it's BMW car is also coated the same materials. Even they are not using a wipers for cleaning of glasses. So even in 200 BC or 300 AD, they are used that even Tipu Sultan also. So Damascus steel, or even in Shivaji case also, they developed the Indian sword, that is wood steel was made with a mixture of large quantity of carbon and iron. So basically then the nano concept, a processing, separation, consolidation and deformation of material by atom or a molecule, then will be a more effective. A quick a glance of the timeline of the nanotechnology around the global level. A 4th century Rome has started, then 15th century stained glass windows has started by the nano concept, and the first man who has introduced a nano concept by 1959 by Richard Feynman. So during his Catholic discussion, during his his speech, he was mentioned there is plenty of room at the bottom. Then the scientists started working on that, what exactly it means. Then Nouri has given a clear picture, Nouri Tanguchi was given a clear picture what exactly it is. That's what the nanotechnology. So first time he has coined as a nanotechnology, then people started working on the nano. So with this, IBM has given a scanning and as well as SEM. So because we have to check the morphology of the materials, until and unless if we don't know about the material properties, then it is very difficult to understand its applications. Then Buckyball, the Richard Smalley has started its university in 1985. Then Engines has created by using AFM, that is cantilevers, which working in 1986, the first book. Then the IBM again, they have started working in dog anglia, then carbon nanotubes, then nanomedicines. Now NNI is working launched for the President citation. This is about then about come back to the nature's nanostructures in nature. Also you can see it has a very small bumps, the hexagonal shape on its surfaces. So these patterns are smaller than wavelength of the visible light. A low reflectance and high absorbance for the visible light. So this is what which is existing in the nature. The butterfly is also changing its multiple nanoscale pattern on the wings, and these wings, especially for the male, a morphoretinor appears a blue. And many specific scientific instruments are using this kind of phenomena to analyze the color of light, that is LAB values. And whereas Edelweiss, the flowers covered with a thin halo filament, having the nanostructures on its periphery, and because of this, the color of the flower is turns to be white. And this is the two man, so I want to quote, and now I thought from now onwards I'm using a third man. So that's what I came to know today. Thank you, Subramanian sir. So you will become a nanotechnology in agriculture. I can say you are one of the father of nanotechnology in agriculture. The nanotechnology initiated in India by Professor C.N.R. Rao down the line in 2000. Then even in the DST platform, I think Nano Mission was created by the Professor C.N.R. Rao only. Then green nanotechnology was introduced by the Thrissur. He is from Karnataka, and they started working on the gold nanoparticles by extracting or synthesizing by the tea leaves. And he has also cured so many cancer patients also as a drug delivery system. So this is a quick for application, what is nano and approach and availability. So why we are going for nano? Because of the high surface area and high reactivity, and even it triggers the enzyme releases. Even especially the material what we are using for the zinc, which triggers very effectively for the microbial activity in the plant, and definitely it is having a better penetration also. So the approaches generally we have three approaches: a physical, chemical, and biological. A physical approach is very commonly which we are using by using the high energy ball mills and the high pressure homogenizers you can use, so that you can downsize the materials. And whereas in case of chemical method, you can use a concentrated chemicals, concentrated acids, so that will be converted into a nanoscale. And in case of biological method, if you use any plant sources or any enzyme sources or any microorganism and use for the as a precursors to convert into a nano. So this is the basic approaches. Now the conversion of the nanomaterial is not a challenging job. The conversion of the nanomaterials is a simple process. Technology was developed and proven already. But now the challenging job is we have to make the materials stable. Number one. So number two, we have to use a proper requirement, proper dose, the proper location. That's what it needs to be a precision. So precise material, precise location, precise time. Then it will become more effective. So in the nature, so there are classified as three categories: the engineered nanomaterials. So the natural material and incidental materials and engineered materials. So natural materials, which is a soil colloidal, or the natural materials is happening in and around. So whereas in case of incidental, during the welding or milling or a grinding or a combustion, even while writing, so that's incidental. You can use, that's how the nanocarbon has been developed. So even by writing by using the pencil, there is a lot of accumulation. So that is incidental, which is happening a carbon nanomaterial. Then engineered materials is a developed, it's a man-made material. Even the fullerons are man-made materials. But the challenging, as I'm just mentioning, making into a uniform shape, a regular shape. That's the challenging job. And the disbursement, a agglomeration. So we have to make into a stable material. And we have to see that the material should not bound back, because again, the toxicity, that is challenging issues across the global, across the scientists. So as I'm just talking about the approach, a top-down or a bottom-up approach. So top-down is basically a milling, that's a physical approach. A bottom-up is a chemical approach. So we'll do the synthesis, even chemical as well as the biological. But whereas in case of top-down approach, it requires a more energy for conversion, whereas bottom-up approach, it requires less energy as compared to the top-down approaches. So, but whereas the bottom-up approach here, it is a challenging is we have to make the particles into a stable, but in top-down approach, the particles are stable because they are material-based. Whereas in case of bottom-up approach, they are all plant-based or a biological-based, and which requires a stability studies. And they are more homogeneous also. So this is one of the physical method, a ball mill. We have to use a metallic or a ceramic nanomaterial. Depends upon the cup size. Sometimes we'll go for a 2:1, sometimes we'll go for 1:1.5:1. Depends upon the cup size and the type of the material and type of ball, the variation of the ball, and the milling containers and the ball speed and ball to material ratio. And temperature we have to consider, because why we have to consider? Because there are materials are sensitive to the heat, so we have to consider the temperature. So if their materials are sensitive, then we have to add the cryogenic. Then there is another method. There is a chemical reduction. It is the simplest and very easy. That I just mentioned. We have to use the concentrated materials. And here, what we should consider: what are the precursors, and what are the reducing agent, and what are the stabilizing materials. So these three factors have to be considered while doing the chemical reaction. And third one is the biological method. So biological methods are the cost-effective, environment-friendly. Here we are using a biological-based materials. So biological base is a plant extract. Then there will be a metallic ion exchange. Then there will be a reduction takes place. That reduction will be a color change. That color change indicates is a presence of nanomaterials. So these few factors, whoever synthesizing the nanomaterials, these few factors needs to be considered. So number one is a pH. Number two is a temperature, pressure, time, and environment. and other factors like location, space, and all those things. So a general thumb rule is, as the pH increases, for the most of the cases, as the pH increases, the reduction of the nanomaterials will be smaller and smaller. So, for example, if you go for a higher pH, then definitely the particle size will be smaller. So, and also the temperature. So, we should not increase the temperature. Temperature should not be a more. So, it should be an ambient condition. As the temperature is increases, there will be a negative effect. So, we have to keep the temperature as optimum, as an ambient condition. So, whereas in case of pressure as well as a sonication, so if you increase the pressure, so the dispersions will be a more. If you increase the pressure, there will be a more dispersion. So agglomeration will be reduced. And time is a most crucial factor for the conversion of the nanomaterials. So I am just mentioning the time. So sometimes the color change will not be traced. So color change will not be monitored properly. So we have to see that the change of the color will be the indication of the conversion of the nanomaterials. So these are the various equipment, because once you synthesize, it needs to be characterized properly. So until and unless if you not characterize, then you cannot claim that it is a nanomaterial. So first basic, the presence of element we should know. So the Burr-Lambert law is for visible spectrometer. It will absorbance basically. So we'll say it is the nanomaterial presence. Whereas in case of jetasizer, we'll follow the DLS theory, a dynamic slit scattering. So whether the particle is having under the nanoscale or not. So once we can confirm with the particle size, then we have to check its potentiality, zeta potential. So zeta potential is always gives higher zeta potential, higher stable. Even it may be a positive values or it may be negative values. If it is a higher, definitely it will be a more stable. So we have to see that. Again, that's what I just mentioned. It is a thumb rule again, a pH. So you have to maintain a good pH, and definitely potential will be a good. So whereas if you know the scanning electron microscope, that will measure the particle surface morphologies. So whereas in case of transmission electron microscope, it will give a thickness, a graphic structure, and whereas atomic force microscopy, it is surface characteristics like topography or roughness or hardness. Then whereas X-ray diffraction will help us to understand the crystallinity and identification as well as agglomeration. So these are the wide applications. Just now, Subramanian sir has ignited. I can say it's ignited. So he has touched all the areas. You can say textile. They have touched. Even in the medical, they are going to develop a sanitizer as well as the mask. A healthcare and food and agriculture. Of course, they have developed the wonderful nanomaterials, especially for the zinc. And even they are testing IFCO also, and we're also testing the IFCO nanomaterials. And where there are various industrial applications, electronics, environment, everything. So because of maybe in 1959, Richard might be pointed out, there is a plenty of space at the bottom. So you can say anything, so there is a possible by using the nanomaterials. So this is one example for in a dental sector. So where are the possible use of these materials? So even from the a calcium which is coated on the tooth surfaces, even till the root canal. In all the cases, because one of the project we are working with this dental sector in our own adjunct university from the Navodaya Institute, dental students. So we are working with a complete package for nanomaterials till from the tooth surface to the root canal. So this is how a brief background about the nanomaterials synthesis and approaches. Now let us have the food section. So there are particles. The process takes place with the heat and mass transfer, with the reaction which is happening, even the changing its biotechnical or in the molecular synthesis. That's how we'll do the process in the nano section. And whereas in case of materials, there are particles, emulsions, composites, the structures, and in product development, so whether it is using as a delivery system or a formulation system or a packaging, and the last issue is the safety concern or the biosecurity, what kind of sensors, what kind of tracers are supposed to be used. So this is all the task to be taken care in the food sector, and you can think about in these areas. So in food processing, the development of the food, there are two things we should understand. So what kind of food we are developing, whether we are developing a food inside or food outside. So inside food is we are using a different kind of additives, So like, if the requirement is vitamin C, vitamin D, whatever the kinds is required inside the food, that is, for that, there are the process like emulsion, capsulation, and anti-caking agents. So whereas in case of outside food, like a packaging materials or a wrapping, so again, TNAU has come up with a wrapping technology for the mango, and really I was surprised at the cost of the technology which they have developed, because in the last year we don't know the technology which was developed by the TNAU, because we brought the technology from the USA for same packaging for one of our students. So definitely we'll keep in touch with you in coming days for whatever the technologies developed under the TNAU. So we'll collaborate with you. Definitely we can join hands and guide us for even further improvement, because I mentioned in the beginning itself, so we are a small nano. We initiated this area in 2015-16, but still, in Karnataka, I can say proudly, we have established a very good nanotechnology laboratory and doing well in especially for the farm university in Karnataka. So this is emulsions, various emulsions as already available in oil-based liquid, and emulsifiers like surfactant or lipid-based or protein-based. And basically a creation of the small sized droplets decreases the interfacial tension and plays a major role for stabilizing of the nanoemulsions. So this is already the global level what they're using, even company what they're claiming for the nano materials in case of nano emulsion. For basically encapsulation, then they're using for the delivery for the functional compounds, and neutralize they are using for the beverages, so for functional compounds such as coenzymes Q10 and lycopene, lutein, beta carotene, and omega 3 and vitamin A. So they're already using this emulsion technology. And Unilever is using for the ice cream for softening by using the nanomaterial, and Nestle is for quicker and simple tying addition of the polysaccharides. And whereas the nanocapsulations is the coating of various substances within another material on the nanoscale. So purpose is to protect the materials of sensitive bioactive compounds from unfavorable environmental conditions. So basically capsulation in a vice versa. So either we can keep a drug in the center and polymer may be a covering for the drug delivery system, or your material maybe, your drug may be a micro, and the capsulation material may be a nano in certain cases for release of. So we are using this particular technology for a slow release of pesticides. So even we have submitted the in the DST project. So we have already called for the first proposal is over. First clearance is probably because of the COVID. Second clearance is not yet issued. In the slow release and targeting drugs, and that drug was tested in the field, so it is giving a good result for the pesticides. So application of nanocapsules in the food. So Novasol is already a company. We are in the German. So they have Aqua Novo, a German company, has developed a 30 nanometer micelle to encapsulate active ingredients such as vitamin C and E, and they're working in that. And the Tip Top, George Weston Foods of Australia, sells the Tip Top bread encapsulated or embedded with the omega 3 materials. And so many industries are using a color, different color, and beverages or other food materials of nano encapsulation. And whereas in case of anti-caking agents, to prevent for the lumps, to improve the flow properties, especially for the food or even for the materials, and remove the excess moisture by using these anti-caking agents like alumina nanosilicates, even they are using in milk powder, spice powder, even for the egg mixes also for the anti-caking agent, even sugar also. And whereas in calcium silicate nanoparticles, they are using for the salt. So whereas in case of nano-enabled food packaging, so because we want to make packaging material more stronger and more, it should hold for a longer period. So for that, they are using these different clay materials. Then active packaging materials, copper, zinc, and titanium and gold they are using for the active packaging, and intelligent packaging also. So these are the company which they are using already. The Bayer is using for adopted companies in South Korea, Hyde Brewery and Miller Brewing Company. They are using for these materials, clay nanoparticles, for their beer manufacturing industry, for the developing the bottles and making it stronger. So this is one I just used to say in most of the cases this particular nanomaterials, because most of the people or most of the even across the global level, so everybody will say nano is it is not safe, it is toxic and it is going to harm But one thing we should remember, anything which is excess, definitely is going to harm. So if it is more than the required limit, so it is a minimum or a maximum. So if it is a maximum, definitely it's going to affect. So I used to say, so in a ring finger, you can see, so after 2 years or 3 years, the ring was completely abrasive. So even the size of the ring has got reduced. So my simple question to most of the people, where that gold gone? So the gold is entered inside our body. So that's why the antifungal, the gold, which is very good for antifungal activities, even it is very good for the cancer also. So indirectly or directly, we are consuming the nanomaterials. So if it is excess, it's going to harm. So that should we remember. So, sir, Subramanian sir, so because most of the institutes, so across the country, more than 32 institutes, because probably you might be missed in the Nano Bangalore or ISC, which is organized in 2018. So more than 36 universities have been participated, but somehow the TNAU is not participated. Probably they might not received the invitation, or you might be busy with that. So, but most of the people, the statement was, so using the nanomaterials or consuming the materials which are used, so it is not going to be safe. But sir, until and unless it is not tested, until and unless it is not confirmed, so we cannot claim that. So again, I'm repeating. So sir, please make guidelines for the product which we are developing especially for the agriculture sector and the food, because we are consuming directly. So if it is more than the MRA level, so there is a ban. So if it is well within the level, kindly make a guideline, allow those materials so that the nano concept should reach faster to the farming community. Because we are the 2000 in 2008 itself, IFCO and other maybe some of the universities joined with them and developed the nano fertilizers, but still it is not available, commercially available in the market. It needs to be a lot of testing. Even they have tested, even they have given a sample to us also. We were also testing for the commercial, for the environmental issues or toxic issues, and even certain enzymatic activities. The guidelines is very much essential, and make the release or development of the guidelines as much as possible, sir. Because this same guidelines, what it has released recently, you are aware that it is started making in 2016, but it comes out in 2019, sir. So we took long years making into effect. So there are nano edibles coating materials, which like a 5 nanometers which are using for the coating. Even there is silica nanoparticles they are using, silver, hydrogen oxide, zinc oxide, and even the companies, Sonotech corporations, they are claim that these materials which is acting as an antibacterial. So because any silver, any TI, any zinc, it acts as antimicrobial activities. So if you use a composite material, more than one materials, then that will become more stronger and more harder. So this is one of the challenging tasks they are working in. Even the Cambridge University also they are working here. So this particular challenging task, chip for quality analysis. So especially for the pigeon pea shape. So even inside the grain, it may be a pigeon pea, it may be a groundnut, even it may be a cashew nut, or even it may be a coconut. So what is happening inside the plant, inside the seed, inside the material, that needs to be checked by these materials. So definitely this is going to happen in coming days. So this is the quality analysis, nanotang, then the people are working around the global level. So this is what I want to mention. So these are some of the things which we have worked, and almost, it is tested in our farm universities. So by using the neem, we synthesize the silver nanoparticles and tested for the chickpea, and it is very good for the germination percentage, more than 18-20%, and which is having a very good for zone of inhibition also. And whereas in case of silver, we have synthesized by using the Uttarani, that's Acanthus aspera, and tested for the groundnut, increases the yield of almost 14 to 16% groundnut germinations. And we got a very good yield also. Whereas in case of spinach, got a very good response for zinc synthesis, and same zinc we are using for the different applications also. And whereas in case of tulsi, a copper synthesis and increasing, being the good result. Whereas in case of rice husk, synthesized a silica, and even we are using for same rice husk silica synthesis for development of the packaging materials biodegradable. So this is another technologies developed by our Center for the Water Purifications by our one of the student, and even we got recently a patent for synthesis, and the same student also worked under the Dr. Sudheer sir's lab also, and again because of he got the young scientist and he came back our center, and now he's working in our center. He's none other than Dr. Dinesh. So we have almost three technologies was patented, sir, and one patent is recently granted, and we are commercializing that technology with one of the industry at Maharashtra. So these are some of the process technologies, because we want to start in the nano sectors in the initial stage. This is the process technologies for packaging materials, SPI based packaging material, soya protein isolate based. But we use the base as a soya protein isolate. So please remember, you can use any material for development, but basic protocol is same. So only thing is we should make sure that a sellability, we should make sure that a transparency. So if you make these two considerations, then definitely we can achieve in this particular area. So the another one is silver nanoparticle from the neem. So neem is one of the wonderful plant. I can say it's a wonderful plant. Like as the coconut is a kalparuksha. So for the farming community, I can say neem is a kalparuksha for development of so many materials. Because even our urea is encapsulated with the neem materials. So that's why urea is available in the market right now very easily, very affordably. So I can say affordably. So earlier days, getting the materials itself is a challenging task. But after encapsulation of the neem, then the availability will become very easy. And it is efficiency also, effect and efficiency is very good in terms of applications. So like that, we started working on the synthesis of silver nanoparticles from neem, and which is giving a very good result. And now the application part in the different areas, even the purification of the water which we are using for the neem. And also we are developing certain material for antimicrobial by using the same materials as a surfactant. So this is another one, we got a very good result for spinach synthesis by using the zinc. So almost 5 cycles we have completed now, and getting similar results for its effectiveness in enzymatic activity in the field. So this is another area. So we developed for the juice powder, a bitter juice powder. So everybody bitter is tasty, but after by using the nano spraying and nano encapsulation, so that bitter taste was reduced and effect was maintained similar. So this technology is under commercialization. Even two companies came forward for taking this particular technology. So this is, as I just mentioned, from the rice husk, from the silica, and this is also got a good result. And this is another one is tulsi from the copper, synthesized and got the good result for seed quality. And coming to the agriculture, so for the why you want to go for nano fertilizers, nano pesticides. So this is 3 times increase in the nutrient use efficiency, and 80 to 100 times less requirement to chemical fertilizers. And this is 10 times more stress tolerant by the crop, and complete biosource and eco-friendly, and 30% more nutrient mobilizations of the plant, and 17 to 54% improvement in the crop yield. That's what we observed in case of development of the nanomaterials. Whereas the best nano agrochemicals is if you use a encapsulation and water solubility, and the polycaprolactate and polylactic acid and nanospears were used for encapsulation of these insecticides, ethiprols. So this is so the crop protecting agents. So this acts as a crop protecting agent. And whereas in case of nano fertilizers, even there are people that are using for PiO2 as a nano fertilizer, and zeolite also used, and even zinc, nano zinc, which we are using for the as a fertilizer. So this will help to a traditional method what we are using, and this increases a tremendous growth as well as a chlorophyll content as well as the yield factors. So there are available in the market like nanoporous zeolite, nano zinc fertilizers, herbicides, pesticides, carbon nanotubes, and atomers, and boron fertilizers. So we should see this. Even IFCO has developed these nanomaterials for the different combinations. So the biosensors in the agri-food, a carbon ceramic electrode modified with a multi-walled carbon nanotubes, and a sensor depends upon the variation in the climatic factors, temperature, as well as the relative humidities, as well as the moisture and the pH. So these sensors is going to change its color. So especially for the smart packaging, these sensors will play a major role. So whereas in case of Agri environment, a nanoporous, a silver electrocatalyst enables electrochemical reduction of the carbon nanotube, the carbon monoxides, that will help say 3000 times for the detections. Whereas in case of composites, a polymer nanocomposite incorporating a metal or a metal oxides, so utilized for their antimicrobial actions. So especially for the high aspect ratio and are able to improve the properties performance in terms of the polymers. So whereas in terms of the waste reductions, you can use the transesterification, whereas in case of gasification, pyrolysis or hydrogenation, if you use the calcium oxide and the magnesium oxide nanoparticle, which acts as a catalyst, the carriers are heterogeneous catalyst in the oil transesterification to biodiesel. So this is one of the work which we done for master students, and so the increased efficiency is almost 15 to 20%. Now we are using for the engines for nano biodiesel. So hydroponics, which is another area which we are working, which we have started in the last year. So nano phosphor-based electrolysis lightning devices have the potential to reduce the energy cost significantly, and this light could reduce the energy cost and encourage the photosynthesis in indoor as well as the hydroponic agriculture. So crop improvement is our target. That's what I mentioned about the fertilizers. And the filtrations is one of the area in most cases, either it may be water or basically a water purification systems for chloride, arsenic, or sulfite, or BOD, COD. So these are the most of the challenging areas in the filtration system. So in that, in collaboration with IIT Chennai, so we have installed one of the arsenic removal filtration system in one of the arsenic affected area, like that is Mavanmati in Karnataka. So which is giving an excellent result for heavy metals, especially for the arsenic. And keeping in view that, then we started working on the filtration for the dairy effluent wastewater. Then we have succeeded, I can say we have succeeded in controlling about BOD, COD as well as sulfite in the dairy effluent plant. And now we are installing one of our own product developed at our own KMF, Karnataka Milk Federation unit in Raichur. So this is one of the success story I can say. We have monitored the growth of these nanoparticles and given very good, tremendous germination percentage in germination effect. So this is our success story, and especially for some of the materials which we have synthesized. A green synthesis was done in our laboratories. So these are also used for the drug delivery systems, which is more effective than any other material. And this is just information. Antimicrobial, can use antimicrobial. Even Cotton King has developed are using, even Van Heusen shirts also, these nanomaterials for antimicrobial, even the wound damages they are using. And whereas in case of kitchenwares also, they are using these nanomaterials. Because especially for the cosmetics, they are using nanomaterials, but they are not claiming. You can see all these cosmetics materials, they're all vaporized type. You should just rub it and it will evaporate, but they are more effective and more preservative. And earlier, all these face creams, comes with 6 months shelf life, but now the same materials they are claiming as almost 2 years. So that is the help, or that is the beauty of nanomaterials, converting to nanoscale. So this is a disinfections, air disinfections to reduce the microbial growth in air filters and drinking water, as I'm just mentioning, this is giving a very good result. And biotechnology for the agri-food production, one of the collaborative work is going on in our university for detections of even the what do you call the oil. So basically, so in there is so many mixtures, there are so many ingredients which are using in the oil. So we are using a rapid detection for in the oil. So that's one of the project which we are working in our center. So this is challenges. What are challenges for this particular growing factor, growing populations, and what are things to be taken care? So now the challenges is fuel cells development, solar cells development. The solutions is already coming to existing for nanosilica materials. So supply chain, clean water, a globally requirement. So again, there is a solutions by using the nano iron materials. If you use the nano iron materials and nano silver in combination, that so it is giving a very good clean water material. And whereas in case of productivity of the agriculture, so nano zinc, which acts as a a very good growth regulators and a rest of the other micronutrients, definitely we can meet out the requirement of the food material in the coming days. So making it a technology, a widespread is most important, and cost also important. And improving the health, almost 30 new highly infectious diseases have been discovered in the last 20 years. And for that, a rapid diagnostic kits. So what the TNAU is going to start with rapid COVID kit for even COVID-19. So COVID-19 test rapid diagnostic kits are developed, but still, the success rate is needs to be taken care. So, and healing and preserving the environment. So this is most important. So whatever the nanomaterials is developed, so it needs to be properly disposed. It needs to be properly kept so that there should not be any kind of contamination. So future prospectus, so we need to develop a nano robots, smallest engine ever created, and nano swimmers for the drug delivery system, and nano engines like an ant, so which will help for the transducers, and sperm inspired micro robots, which is very much essential, especially for a kind of deadly disease like cancer. And nano rockets is most important. Even our own ARIC Hyderabad, they are using a carbon nanotubes for coating these materials, and almost all the rockets they are using a carbon nanotubes for making into reaching the destination very precisely. So these are the areas what theme, application, and probable type of technologies can be used. This is for just glance, because we can start the sector, not to search which sector I should start. You can start the sector, you can choose the theme, you can choose the area, and you can the technologies are available. So as an entrepreneur, as a scientist, or as a student, as a farmer, so we should see what is the requirement and what kind of technology is available, and we have to select and we have to take away. So definitely then only there will be a success. Until and unless you cannot take the technology, you cannot choose the technologies, then there will be a less success ratio. There are various concepts are available in terms of value addition, in terms of a delivery system, so in terms of horticulture chain. So even the basic requirement, what I can say, awareness is most important in the field of nanotechnology, even in the field of agriculture, even in the field of food, because this is most important. We have to more focus on awareness, because I may wrong or I may right. So why the BT is not popularized, why the BT is failure in the country, probably there may be a not proper guideline, and probably there may be a not proper awareness for the society. So the humble request to our Honorable Director of Research, Subramanian sir, again, sir, you make a platform for the awareness, especially for the nano. So that definitely the technology will reach to the farming community very faster. And of course, the toxicology aspects is most important in the nano. So NNI is working on that, and even across the country they are working. But sir, we are getting very late answer. They are taking a lot of time for this particular area for assessment. So with this, it is a bring to next revolution. Nanotechnology in the field of agriculture will become a next green revolution, next kind of we have crossed the green revolution. Definitely there will be in food and agriculture. Definitely it will be a next nano revolution. A technology such as encapsulation and control release are two methods will revolutionize the food processing and agriculture, because we have to release the materials whenever it is required. So then only it will be a more effective, and care should be taken while designing the nanomaterials. So sir, there is a next big thing is a very small, so that is a nano. So thank you very much, sir, especially Dr. Sudheer sir, for giving me an opportunity on this great platform by organizing by KAU under the leadership of you, sir. We did a small, so definitely we can collaborate with any institutes, and already you know very well we have submitted under your collaboration one of the proposal. Definitely we're expecting soon, sir. Thank you very much, Dr. Subramanian sir and Sudheer sir. Thank you, sir.
Thank you. Thank you, Dr. Sharangouda. And I told one encyclopedia. I think we are seeing many encyclopedias now. Okay, because you have also done, because though Subramanian sir started pretty long back compared to you. Okay, naturally it has well established because of his hard work and also the ability he has put into, and the international collaboration and all that we have seen the output from the TNAU Nanotechnology Center. So now to both of you, many questions are there, okay, in the chat box, and I think first questions, I think it was supposed to Dr. Our Subramanian sir, because your presentation was not started. So I think this question, two question, I think Subramanian sir can answer. One is encapsulation of bioactive components. When we are going for the bioactive component encapsulation, the oxidation, how